Hello everyone, my name is Jaime Font, and I'm here in representation of my co-workers Daniel Blasco, Zamorano, and Carlos Cetina. We are all members of the SBIT research group from San Jorge University, and during the next 10 minutes we would like to show to you our entry for the 18th Annual HUMIES Awards, our evolutionary approach for generating software models, the case of Kromaia in game software engineering. Enjoy! What we have seen is the official trailer of Cyberpunk 2077, the latest blockbuster from the video game industry, and it was set to become the biggest hit in a multi-billionaire industry. Unfortunately, a decade of development, the large budget, or even the involvement of Keanu Reeves as the starring role in the game have not been enough. The game is not fulfilling the expectations and hype created. The release of the game was delayed several times, developers were forced to crunch, and when the game was finally launched, there were so many bugs and glitches that it was unplayable. The company's stock prices plummeted, and they were forced to refund the money to thousands of unhappy players. Crunch is the answer from the industry to the increasing complexity of video games, the tight schedules and release plans, and the underestimation and bad planning. It puts pressure on video game developers that are forced to work during unending days and sleepless nights to be able to bring a video game to the market. The International Game Developers Association has been monitoring the problem for years, and they report that the problem is not only affecting the giants of the industry but also small studios. Developers have become severely underweight, slept in their office, and spent whole weeks without seeing their friends or families just to get a video game out of the door within the strict deadlines. Our evolutionary approach has the potential to be a game changer for the industry of video game development. It was able to produce the bosses that the player encounters while playing the game and must defeat to advance to the next level, obtaining human competitive results. The content was produced for Kromaia, a commercial video game released in both physical and digital editions worldwide for PlayStation and PC. The game was translated to 8 languages, and the development of the game took more than 5 years, including crunch days. This is a screenshot from Kromaia. It features a 3D world where the ship controlled by the player can move freely. Eventually, the player will find a boss enemy. In this case, the boss is called Vermis. Our evolutionary approach is applied to build bosses comparable to the ones shown here. Bosses are composed of different hulls that are linked together. Different types of hulls or links are used in the game to obtain different architectures and behaviors. In this case, the boss resembles a snake. Hulls can be covered with seals that must be destroyed by the player to be able to damage the boss. Hulls can also be equipped with different types of weapons that will exhibit different behaviors. In this case, the boss is equipped with cannons that will track the player and shoot bullets at it. There are other types of weapons as spikes that will damage the player by contact. Kromaia is considered a complex and fun game by the community, and it has won different national and international awards. In particular, the Best Game Award at 3D Wire, the Best Design Award at HoPlay, and the Best Technology Award at Game Lab. Our evolutionary approach success at the scale of a multi-award winning video game such as Kromaia and has been used to produce bosses comparable to those included in the commercial release of the video game. Each of the bosses produced is created as a software model that is composed, on average, of more than 1,300 model elements representing the different parts used to build the boss, more than 1,000 relationships among the different parts of the boss, and more than 15,000 model properties used to specify the details and behavior of each of the elements. So, What is the secret of our evolutionary approach? In traditional software development, the developer creates a source code that is then compiled into binary code that can be executed by the CPU. On top of that, software models have been used for decades to ease software development. They can be used to facilitate the communication among developers that are writing code when used in the form of a sketch. They can also serve as the basis to create the code using a software model in the form of a blueprint. But they can also be used to fully replace the source code using the software model as a program. When the model replaces the code, an additional compilation process is needed to transform the software model into source code. Traditional genetic programming approaches found in literature are applied at the level of source code, applying an evolutionary approach that generates source code. However, there is a limitation imposed by the noise introduced by the implementation details of the source code language being used. Similarly, if we try to procedurally generate binary code, the noise is even higher, as we need to account for too many details that are not directly related to our problem, but to the underlying software platform being used, leading to low success. Our work is a conceptual leap forward for genetic programming. It contributes to the rise of what we name genetic modeling, where software models are used as higher level specifications with exponentially less noise than programming languages. The models are evolved to fit a specific task. In this case, models are evolved to specify bosses for the video game. The major advantage of modeling languages such as UML is that models use concepts that are much less bound to the underlying implementation technology and are much closer to the problem domain, enable them to efficiently build systems more complex. We state that the video game content produced by our approach is human competitive because we successfully compare it to the video game content produced by human developers by means of fundamental and measurable indicators accepted by the video game community. We use 6 different indicators designed to measure the quality of a video game: completion, duration, uncertainty, killer moves, permanence, and lead chains. In addition, to produce the human competitive results, our approach only took 5 hours of unattended time in comparison with the 10 months of work spent by the video game developers. This data was obtained from the version control system and it was confirmed by the developers. This drastic reduction in time is what makes us state that our approach can help the video game industry in avoiding or at least reducing the crunch days being suffered by the developers. The results were so striking that they soon attract the attention of core Spanish news media and are starting to attract the attention of South American news. This is an extract from one of the biggest news media of Spain, where our approach was featured being the second most read entry of the technology area. We even rivaled politics, being the hottest topic those days. Among all the questions from reporters and audience, which include video game developers, one question prevailed from interview to interview. Does this new approach make video game developers redundant? Regarding the impact on the industry, we applied for a European patent and extended it to a PCT patent. We hope that soon our approach will also share another facet with human developers, the capability of making money. The approach is also attracting the attention of video game companies. Multi-award winning video game studios such as Kraken Empire and Tequila Works, as well as industry giants as King, the developers of the well-known Candy Crush video game saga. To conclude our presentation, please let me ask you a question. Can you distinguish between the video game content created by your genetic modeling approach and the video game content created by human developers?